In this lesson we are going to talk about translucent or subsurface scattering materials, and they are, relatively speaking, transparent in their nature, but due to their specific physical properties, light will bounce within those materials. So let me grab my doodle tool so I can help you visualize that, and we'll use this trefoil or trefoil. I'm really not sure how that is pronounced, but it is a funny looking object, and I will use it to explain that translucent material. So when light hits the object, it either penetrates the object, which is obviously then transparent object, or most of the light is reflected outwards in case of a very reflective object. Now, there is a special phenomena with certain types of materials. So when a light enters in a semi-transparent object, it encounters small particles inside that object, and then that light hits that particles and bounces off in, well, let's say random directions. So that would be a physical explanation of what subsurface scattering is. So scattering of light beneath the surface, obviously. And you would be really surprised to see how many materials in a real world exhibit this behavior, even ones that you wouldn't expect, such as marble, for example. Now, let's actually get rid of this little guy, and I will show you that on a really simple example from Wizard, which contains this SSS material. Now, some of you may notice that we have really odd looking materials here, and those are emitters, which we will talk about in our next lesson. But I will just mention that in this scene, environment is set to none, and this none doesn't mean that we will have no environment. It simply means that we won't use sky dome, physical sky, or image-based illumination. Also, the sun is disabled, and our scene, this particular scene, is completely lit with artificial light. So we will talk about that in next lesson. So let's concentrate on those subsurface scattering materials. So let's create a new translucent material, and we will leave everything at default so we can use that as a starting point for explaining those materials. So let's hit OK. We will create a new material, and as you can see, we have kind of grainy and mushy results, or greasy in lack of a better term. And let's actually switch to this BSDF and see what is happening inside this material. Now, if you absorbed everything from previous lesson, you could say, well, this guy should be transparent because the color is light here, which basically says that this should be transparent. It has a attenuation of almost 3 centimeters, so the light should penetrate 3 centimeters inside. It has a really low ND, even lower than water, so why is it not transparent then? First idea would be, well, it's simply too rough maybe, so that is why it is not transparent. So let's give it a shot and lower this to 0, and it is still not transparent. So obviously these settings here are responsible for this material not to be transparent. Okay, I hope that makes sense. And as you probably noticed, these subsurface scattering materials render slower, at least in this preview. So I warmly suggest that you switch to this SSS preview, which will render these materials much faster. And now you can actually see some of the properties of the material. So what is happening here is that we have exactly what I was doodling at the beginning of this lesson, and that is scattering of the light from the particles inside that object. So the amount of particles inside the object is controlled with this coefficient. That is this value here, this Asymmetry is something that we will talk about, but not at this moment. And if I lower this to 0, I will get a completely transparent material. So, for example, if I change this to our stage 1 preview, which is very nice, you can see that this object is actually transparent. Nothing else happens. So by setting this coefficient, you're basically saying how much of particles will be inside that object. So if I put this to 1, you will see tiny specks of light happening inside the object, and as I increase the value, the number of scattered light will increase. Now I will change this back to this SSS preview because it is much faster, as you can see. And if you are wondering what this color here does, it's simply a color of those scattered particles. So they don't have to contain default color, they can contain any color. So let's maybe load something crazy like maybe this one. And you can already see that the object becomes a little bit tinted with that color. So if I put this to 100, then we will have more and more of that color, which is a color of scattered particles. Now do note that the higher this value of coefficient is, the slower the render of your material will be. So some maximum values I would recommend here are around 3 or 4000. I really think everything higher than that is completely unnecessary, but of course you are welcome to experiment. Now we will delete this guy and we will create a translucent material from scratch, and that first material we will create will be honey, because it is something you can relate to, and I believe it is a great example of translucent material. So let's actually open this guy and create a new material like this, and we can rename it honey. And let me show you a rough guide how you can create your own SSS materials, and I would strongly suggest you start by setting the reflectance 90 and 0 to black. So that is a first step. The second would be to create a material that is only transparent and doesn't contain any scattering, but that transparent material should resemble maximum of what you can achieve with just transparency. So in my mind, honey is roughly of this color, maybe a little bit darker. So use your artistic sense here, and if I would have to say how much light penetrates inside honey material, I would say something roughly around maybe 3 centimeters, something like this. And let's force the Fresnel, and of course we have to lower the ND, so maybe something around 1.3, which is roughly the value of water. And honey is not completely transparent, it is a bit rough, so let's maybe go with 5 or 10, we will see later. So this is as far as I can go in creating honey material without this scattering. So now, once that is done, I can set the color and coefficient for my scattering that will happen inside the object. First, I have to determine the coefficient or the amount of particles that will exhibit that scattering behavior. And in honey, which is quite transparent, this could be something around 10, maybe. Let's see. Maybe a bit higher, maybe 50 or so. And for this scattering color, good practice is to load the transmittance color first and then use that color or a derivation of that color. So maybe I will go darker here because I want this honey to become darker as the light penetrates, maybe even a bit more, something like this. And let's even increase this to 100. And you see this preview is quite slow, so I will change this to this specific type, and this is roughly our honey. So let's actually apply that to our object. I will enable its visibility in the render, and let's see first with the fire preview what do we get, and it actually looks decent enough. Maybe I'll just change this color to be a little bit more bright. Let's even go with high orange. Now this is too much. So look how tiny changes in the color can produce very, very different results. So let's actually now render this, see how it works, and it looks decent enough. But you see these little guys, this is actually something that you don't want, and Fire Render produces them because it is just a preview render. So if you want full quality, then you have no choice than to switch to this production render. So let me render this out. So I will let this guy render for a few minutes, and we'll show you the result. And here we are after just a few minutes, and take a look at that. This is absolutely fantastic. So it really has that quality by itself. So creating such materials is really not a problem at all. And take a look at those reflections and caustics, and they really didn't clear up in this area, but that is not the point I'm trying to make. So let's get back to Cinema4D, and let's actually create another material for our next object. So I will hide this guy and will enable this pudding. So this will be interesting. So let's create a new material. Once again, same recipe. We'll put these guys to black. I will lower the roughness all the way and set the ND to 1.3 or 1.25. So I really want a very transparent object, and let's choose a nice color here. So maybe let's go with this one, which is really strong and vivid, and I have to determine for this pudding material how much, relatively speaking, a light will be able to travel inside. So I guess that would be something around a few millimeters instead of a centimeter, because pudding is not really transparent at all. It has that mushy feeling, but it's not transparent in true sense of that word. So let's find millimeters, and let's try maybe 5. So half a centimeter, and we will give it a slight roughness, because pudding is not completely smooth surface. At least this one won't be. So slight roughness, better something than 0. And since I will be increasing this coefficient, the preview render will become slower. So I will choose this preview, which is designed for SSS materials to render faster. So let's first introduce some scattering, and in pudding, because I want it to be a bit more dense, I will have to increase this number to something higher. So let's start with 100. Not really, let's try 300. That's a bit more dense, but I want even higher, so let's go maybe 500. That's also too low. Let's go maybe 750. And I think this could work. Now let's choose a color for that scattering. So for that light that will be scattered from the particles inside, and it doesn't have to be this color. So we will break that rule here by selecting something else, and let's go maybe with this bluish color, because I think this will be good enough. And yes, that will actually be great. So let's close this, apply this to our pudding, and let's do a fire preview like this. And actually the object didn't refresh, so we have to manually force the refresh like this, and that is quite good. So maybe this is a good time to explain this option here. So basically, without going into really geeky details, this guy says how much asymmetrical scattering of that particles will be. So let's actually doodle that. It's much easier to understand that way. So light is coming in, it hits the particle, and if you have no asymmetry in your material, then the scattered light will be equally sent in all directions. I'm really oversimplifying this, but I think you will get the point. But when you introduce this asymmetry, then the light will not be scattered symmetrically, so maybe it will go a little bit more towards outside and less inside. Okay, I hope that makes sense. And really, the best idea here is to experiment a bit. So let's just say, as a really simple rule, that increasing this value will make our object a little bit more thick and brighter. And on the other hand, if you lower this guy, the object will appear darker and, in a lack of a better term, a little bit more transparent than without any setting. So for my pudding, I actually want it to be brighter and to appear more solid and to be more vivid. So I will increase this to maybe 0.3, and you can see the difference. So it appears a little bit more solid. So let's say that this is good enough, and there is one thing missing from this pudding, and although I'm very satisfied with the quality of the surface itself, in my mind that pudding should have a thin coating of a very reflective surface. So I can add a coating, simply set this to black, as we already saw, and use very low value here, so something like 1.2, and I will force the Fresnel, so I will get that reflection on my pudding material. Now all there is left to it is simply to render this guy. So let's do just that, and we will render it with our production renderer. And these subsurface scattering materials unfortunately take longer to render because of the calculations that will be happening inside the object. There is simply no way around it. So let me pause this video briefly, and I will let this render out for a few minutes just to show you the result after it renders sufficiently. And here we are after a few minutes, and I'll let this render to achieve a sampling level of 14, which is still rather low, but I think you can judge the quality of this material really well. I really like this subsurface scattering in Maxwell. It produces fantastic results, and the look and feel of materials is really realistic. So let's actually close this now, and since those SSS materials are so good, let's actually create one more as quick as we can. So new material, once again same recipe, and let's already choose a color here. So this one, attenuation in this case should be something really low. Let's maybe go with let's say 4 millimeters, and ND should be around 1.25. We will force the Fresnel, and let's put roughness to something around 10, and this is what we get. So now we'll simply choose a derivative color, and I'm pretty sure that you concluded that I created those color presets prior to recording just to cut down the recording time. So let's introduce some scattering now. Let's start with 100. This looks good, but actually let's change the preview to this specific one, and I think I will need more particles, so maybe something around 350, maybe even a tad more, maybe 450. That looks pretty good, but let's just be sure go with around 500, and I think this will be good enough. So let's actually apply that material to our horseman and do a quick fire preview. So we have to refresh. I think this will be quite good. So let's stop this, and we will do a production render. So let me render this guy also, and I will be right back. And here we are after just 20 minutes or so, and you can see how great this jade material turned out to be. So all subsurface scattering materials are very realistic and lifelike, but unfortunately they take a little bit longer to render. So let's go back to Cinema4D because I want to show you something else, and that else is that you don't have to keep these reflectance colors to be black. And in fact, by adding a certain color, you can create more diverse and realistic surface. So let's maybe select this orangey one. So I introduced a little bit of that reflectance color into this overall material. So feel free to experiment with these colors also. And here under wizards, under these SSS presets, you have a bunch of pre-made materials, so you can really deconstruct them and see how they were made. Okay, that's all for this lesson, and in the next lesson we will talk about emitters. And this scene, as I said in the beginning, is lit by emitters, which are in fact simply artificial light. So let's proceed to our next lesson.